Thank you for attending this session on opportunities for mobile applications in the 3T environment. My name is Craig Johnson. I'm with the MITRE Corporation. If you're not familiar with MITRE, I'm just going to give a quick intro because it does have some relevance in terms of where this work goes in the future. So MITRE is a not-for-profit organization. We do operate federally funded research and development centers. The center I support is the Center for Advanced Aviation System Development, which is sponsored by the FAA. So this work is being done by the FAA's Next Gen office as a concept exploration and maturation effort. So why that's important is, MITRE doesn't commercialize or sell products. So everything you hear me talk about today is strictly research prototypes. In order for this stuff to continue on for use by pilots in the future, it's really going to depend on industry sort of picking up and carrying these things forward. So keep that in mind. I'm joined here by Dean Ernie Stellings. He introduced himself this morning.
You guys got to hear me talk really fast earlier, so I'll try to just sit here and shut up for this one. No, I'm kidding.
Thanks, Ernie. I want to also acknowledge my colleague who couldn't make it here this week, Paul Diffenderfer. Some of you guys may have met him. He's really been instrumental at MITRE in terms of advancing and really pushing the envelope on some of the mobile work that we're doing. So with that, we'll jump right into things. All right, there we go. So as I get into the presentation, I'm going to kind of cover a few basic areas. I'll start off with a few slides to provide some context for why we're doing this research, what's the motivation. I'll go into some explanation of operational environment and our target users and how they're kind of different than what the airlines are doing and how we kind of had to think about this problem a little bit differently. Then I'll go over and explain at a high level some of the applications that we're currently researching and where we're exploring those efforts. And then I'll move into some lessons learned and some technical considerations that we encountered along the way that hopefully would be useful to anyone who's interested in carrying these type of applications forward. So in terms of kicking things off, I think a lot of this intro has probably been covered already. I mean, I think everyone's aware that there's a lot of surface and departure related research going on. ATD-2 is obviously one of the major ones. And so that's providing an opportunity to explore some of these concepts in an operationally relevant environment, which is great. So we're very appreciative of NASA working with us to allow us to bring some of these mobile concepts into their project. At the same time, the FAA is making investments in new surface automation. You've heard a lot about TFDM already. These systems, both ATD-2 and TFDM, work better when they are provided with better inputs. So that's really where this research is going. And then as a whole, the NASA is transitioning to more time-based management, less of the miles on trail. And so again, that depends on having better inputs from flight operators on what they're planning to do, so they can feed in to the systems that are coming up with these time-based management plans. And with these new systems, it's opening up a lot more data that's available to be consumed and different ways of consuming it, even on mobile devices. So that's kind of where we're headed. So when it comes to departure management, you've heard this I think a lot already as well. Uncertainty makes this environment challenging, and it's really uncertainty around when an aircraft is going to be ready to go. That's kind of the starting point that kicks everything off. Once you can kind of nail down when aircraft are ready to go, everything else kind of starts to fall into place. So there's obviously a lot of factors that influence when an aircraft is going to be ready to leave. I listed a few here. A lot of these are more geared towards the airlines, but some of them also are applicable to other flight operators as well. But the bottom line is that in most cases, the flight operator is really the best source of this information regarding the status of their flights.
And especially for our community, you know, the biggest uncertainty is really, you know, our customer in the back and when they're going to show up. And that's what I was talking about earlier this morning. You know, that's the challenge, is trying to get them to provide more predictable information so that, you know, the times are more accurate than what they used to be. And so, you know, we've had some success. I think you have a slide in here showing the Charlotte stuff that'll show you that they've been really good about it. But as we roll this out into other airports and so forth, and from the NBA perspective, you know, there's a lot of work we're going to have to do to educate those guys to get them up to speed on using this. But the app's really going to help.
Thanks. So moving to another source of uncertainty as we kind of set this problem up. So at an airport like Charlotte, where ATD-2 started, you know, that airport is predominantly you know, airline driven. Most of the operations are from the major airlines. So if you can get, and you know, most of those airlines in Charlotte are either providing better awareness of when they intend to depart or in the process of doing so. So if you can get all that information and everyone at the airport is providing it, you know, that really helps lower your you know, the degree of uncertainty that remains. But as you've heard also this morning, you know, when you've seen one airport, you've seen exactly one airport. Not all the airports have that makeup of operators. As you move to, you know, a place like Las Vegas, or even just, you know, down the road at Dallas Love, you know, a typical day's operations may include 30 to 40 or 25 to 30% of you know, unscheduled operators. And what we're really talking about is the GA and business jet communities. And certainly at Las Vegas, you know, it's unique in that when they have a special conference going on or sporting event, you know, sometimes that mix of non-scheduled flights can creep up to 40 to 50%. And then at the extreme end, you have airports like Teterboro, which are almost exclusively non-scheduled flights, and with it being in the vicinity of the busy New York Metroplex, that, you know, creates its own challenges. And so, you know, if you imagine, you know, these flights that make up these orange wedges being, you know, not participating in providing better awareness of when they plan to depart, you're leaving a large portion of uncertainty that could really impact the operation of the airport, you know, for everyone. So that's really what's driving is you know, how can we you know, look to include the general aviation and business aviation flights in this operation, where they can participate and they can provide you know, similar departure readiness information that the airlines are providing. Because right now, the airlines are using their operation centers and are connecting to SWIM to send this information to the FAA, or in the case of ATD-2 to NASA by way of SWIM. So we're really looking for, like, how would GA you know, participate in this, because they don't have the large operation centers, they don't have big IT departments. So we really needed a solution that was more lightweight and more conducive to you know, low volume operations. So that's really where you know, the aspect of can mobile technologies, you know, fill that gap. So this is something we've been investigating for a couple of years in collaboration with the FAA and NBAA, as well as NASA as part of ATD-2. I know Ernie and his counterparts have you know, been promoting the possibility of mobile technologies through the surface CDM community. And so we've connected up with them. We had been doing some mobile research into using mobile devices to get pre-departure clearance information. So we had a lot of the back-end infrastructure in place to support, you know, additional applications like, you know, collecting this departure readiness information. So that's kind of how things kicked off.
I'll just say one quick
yes,
thing to
go
that.
ahead.
And so when they approached us about Charlotte, you know, first thing we did was we looked, and you know, like you said, it's not a huge percentage of GA that operate there. I think we had maybe 11 member companies or something like that we went after, and we just got them in a room. We said, hey, you know, we told them what we're trying to do, and let them volunteer to sign up or not. And so over the last 2.5, 3 years or so, you know, we've had pretty good participation. Now that we're with Love, We've approached the pilot roundtable groups there, and again, the locally based members that are ours about the same thing, getting those pilots on board too. And then with Vegas as another option, so now you've got 3 good airports to try this stuff at, you know.
Yeah, now Charlotte's been a good place for us to do some concept exploration. Like Ernie said, the percentage of GA operations is only 4 or 5%. So that allowed us to do some more targeted user engagements with some of the operators there, and really get some back and forth feedback from them on what works and how does it fit into their operation, which kind of leads into this next area, really understanding the user environment and how are GA operations different? What do we need to do differently than what we're doing with the air carriers in terms of collecting this information? And it really kind of started with understanding, how do these flights operate, and what are they thinking about? So you probably heard early soft block time, EOBT, that being the data element that provides that better awareness of when flights are going to operate. So the notion of EOBT, doesn't quite equate to the GA environment. They aren't typically pushing off a gate, or they don't deal with blocks of time. They're typically situated on an airport in another ramp area. It's much smaller than the airline ramp areas. They're situated pretty close to a taxiway, so when they're ready to go, it only takes them a minute or two to get to the spot. They're not talking to a ramp operator. Their first call is usually to the tower. So all of these things kind of we needed to put things in terms that are understandable to GA, because when we asked them, what does EOBT mean to you, or have you heard of that, most of the time we got blank stares, or we don't know what that means. So we sort of defined EOBT for GA to mean, when are they going to be ready to taxi? And that means when are their engines running, they're loaded up, and they're at the spot ready to call a tower for taxi. And we started to not even use the term EOBT. We usually talked about it in terms of ready to taxi or departure readiness time, because those things sort of make sense, to the GA, BA pilot. So the other thing when it comes to planning, or how these group of operators plan, particularly the business jets that are ferrying passengers, from one destination to another, it typically starts with them coming up with an estimate on when they expect their passengers to show up. So in this example, they would expect their passengers to show up around 1500. So what they'll do is they'll file their flight plan with a expected departure time of 14:45. So they'll back that time up of when they really expect the passengers to arrive, just in case they show up early, but also because they want to make sure that they have a valid flight plan. So a flight when a flight plan is filed, it's typically good for 30 minutes prior to that proposed departure time, up to 2 hours after. In some places it's 3 hours after. I think in the Dallas area they've expanded it to 3 hours. So what we found in talking with these group of operators is that they're really using that proposed departure time, or the P time in the flight plan, to just give them a valid flight plan window, and it's not really a good indicator of when they really expect to depart. So that's one reason why we don't want to use that time as a surrogate for an EOBT, because right away we know that the times pilots are providing are often incorrect, by on purpose. So after that, once the passengers do show up, it typically takes them about 10 minutes to get them loaded and ready to taxi. So this time over here, 1510 Zulu is what would really correspond to a true EOBT, and that's really what the time we're after from these flight operators. And so that's not something they're typically used to thinking about or used to providing. So it's kind of something new. We also did some analyses to look at not just the feedback we got from the operators, but we actually went to some data and did an analysis to see, based on the times in the flight plans for GA aircraft, how far off were those times from the actual time when the flight was ready to roll, and on average it was 25 to 30 minutes. So that's kind of the error we're working for. You've heard NASA talk about ATD-2, that they want to do no harm. So what we were looking at with this concept is, can we do something that's at least better than that? Because sometimes no data may be better than bad data. So we wanted to make sure we weren't putting in even worse data than what we already had. And so I have some more slides on data quality coming up here in a minute.
So when we talked about earlier that cultural change, that's exactly what we're doing here with these guys is getting them to be more predictable with when they're planning to really go, because like I think Rob said it earlier, we've really never looked at it from this perspective. We always look at wheels up to arrival time. No one's really looking at the gate on both ends in terms of metering and all that kind of stuff. And so for us, they don't even know what that is unless they operate in Europe or something like that. They usually are on demand, go when they want to go, that type of thing. So educating them on the importance of what we're trying to do here, especially at some of these bigger airports, is what we're trying to get to this next couple of years.
Okay, so then in terms of just, from a high level, the general idea or the concept is, if we can get these pilots to provide an indication on, when they expect to be ready to taxi, use a mobile device to submit that information that would go through, some sort of service provider who's providing this capability via SWIM that would feed into FA systems, which that time could then trickle down across any system that's doing demand predictions, whether it's for surface demand like what we're doing or NASA's doing in Charlotte, aerospace demand, which is conducive to kind of what we're doing here in Dallas with departure fixed demand. And even, it could be even looking at improving arrival demand, particularly for those short haul flights. So there's lots of applications that this type of data could help improve. And then, it opens up the possibility of being able to send data, back to that pilot via the mobile device. So as these scheduling systems, churn on all of these updated departure readiness times, they'll begin to put together a plan or a schedule for the surface, let's say, and they can provide information back to the pilot on when they can expect to get off the ground, or if they're subject to surface metering, you can provide the TMAT, back via the mobile device. Okay, so moving into how we're applying this research. So we're doing that in a couple of different areas. Ernie alluded to a few of them already. So we have prototypes in place at 3 airports, one being in Charlotte, which is where we started, and then more recently at Dallas Love Field. And then we also have a prototype in place at McCarran in Las Vegas. But they're a little bit different. So what we're doing with ATD-2 and what we're doing in Vegas, and I've tried to highlight some of those differences here on this slide. But with ATD-2, we're really looking at what we call like tactical readiness time. So this is like less than an hour before you're ready to go. Can you give us a better indication on when you think you're going to be ready to taxi? So that's the kind of information that a surface scheduler can use to help come up with like what the runway schedule will be, and if you have a TMAT, what that TMAT should be. So it's much more tactical. What we're trying to do in Las Vegas is something that's a little more strategic or further out looking. You might almost equate it to early intent information that airlines provide. So this would be a situation where, and this is somewhat unique to Vegas, but they'll often have these sporting events or conventions over the weekend. So they'll get a lot of inbound flights on a Thursday or Friday, and then on Sunday when the event is over, they all want to leave at the same time, and so there's a big rush. And so that presents a lot of challenges to the airport and traffic management for how to deal with all these unplanned or unknown flights that are all want to leave at noon on Sunday. So can we provide a capability that allows pilots to enter a time similar to an EOBT, but it's more like on Friday when you arrive, let us know when you think you might be wanting to leave on Sunday. And then we can start collecting all that information from all of the pilots, and then put together essentially a demand graph, like something you might see on Google when you Google a restaurant to see when its busy times are. So make that information available back to the operator, so they can make a more informed decision about when they might want to leave. Because what's unique about the general aviation community is that they're not constrained by the same schedule that the airlines are constrained by. They have a little bit more flexibility to go a little bit later, go a little bit earlier, but today they don't really have any insight into information that would help drive them to make a better decision and to move out of those busy peaks and into the less busy valleys. So the work in Vegas is looking at can we give them that better insight into what the demand situation is going to be, and can they use that to make better decisions. These efforts also vary in terms of the resource that's constrained, that's being managed. So in Charlotte, it's definitely the surface. That's also the case at Las Vegas. At Dallas Love Field, the surface never gets very congested, but the challenge is those terminal departure fixes, particularly when weather moves in and reduces the capacity. So the target that the information is being used for is a little bit different. And then in terms of that two-way, being able to send information back to the pilot via the mobile device, so that kind of varies based on application. So in Charlotte, because there's a surface metering capability there, that's producing a lot of new information via the TTP feed. We can subscribe to that and then forward information back to relevant pilots about what runway to expect, their target takeoff time, if there's any TMIs or delays that are going to impact their flight. So this is information these pilots usually don't get until they are contacting tower and getting ready to taxi. That's when they'll find out their runway or if they have any delays. And so they really like getting this information ahead of time before they even get on the plane. They can go ahead and pre-program their FMS for the runway. If they're being told, expect a 20-minute delay, they can keep the engines off until it's really time to go. So that's been a big benefit for them. At Love Field and McCarran, since there's no surface metering there, we're really relying on that surface demand picture, so these bar graphs that look like kind of Google busy times as the kind of carrot of things we can provide back. So in terms of some of the research questions that we're looking to answer, one, we're trying to make this process as simple and as easy as possible for pilots. So we're looking at various ways of inputting this information, and I'll talk about some of those ways we're doing that. We're also interested in what sort of data are they interested in getting back. I talked about the estimated runway, estimated takeoff time, things like that, and when would they like to receive that information so that it's useful. So we're looking at the types of data we can make available back. We're also researching, as I said before, data quality. So we want to make sure that are the pilots capable of providing an estimate that's good enough or at least better than the information we have today. And then as we learn lessons across these various activities, we're obviously feeding them back in to continue to refine and advance the concepts. So when it comes to submission accuracy, I don't know how well this translates. So what you're seeing here is some data we collected from Charlotte, some of our participating pilots. Each dot represents a departure readiness time that a pilot submitted. And what you see right here, this y-axis at 0 is their actual movement area entry time. So that's when they were ready to go. And so moving out to the right along the x-axis is the minutes before taxi. So that's kind of the look ahead time. How far in advance did they submit that time? So what we were going for was up to 45 minutes out. You can see most of the dots are within plus or minus 10 minutes of when they said they were going to be ready to go. So that's obviously better than that 30-minute time. If we were to just use their P time in the flight plan, we're already better at 45 minutes out. But the sweet spot is really that 15 to maybe 20 minutes. You can see most of the dots there are within plus or minus 5 minutes. So that's pretty good. So that tells us these pilots that were participating in Charlotte are pretty good at providing a better indication of when they're going to be ready to depart, at least compared to what's in their flight plan. Now, what's on this chart is really just their last submission. So some of them may have submitted something earlier and may have refined it. So that's why you see a large clumping as you get close to zero. So that's probably not very fair. But anyway, for the most part, we were pretty pleased with these results. Okay. So moving into some technical considerations and some lessons learned. So I mentioned we explored various ways that pilots could provide this information. And in Charlotte, we started out first with a native application that was developed for an iPhone. So it works on the iOS platform. It's pretty slick, very user friendly. All of the typical scrolling, swiping gestures. And so we were pretty proud of it until we rolled it out, and then we realized that there's some shortcomings, particularly in a research environment with trying to roll out a native app. Part of it has to do with having to go through like an app store. So because this is a prototype, we were actually going through Apple's test application store, which is called Test Flight. And the challenge we had is we were constantly making updates and tweaks to the app, and it required users to go in and manually update the application every time we did that. So we struggled with trying to keep pilots up to date on the latest version. And because we're not a very large shop and developing mobile apps isn't our prime business, we couldn't support other platforms like Android or other phone operating systems. So we were limited to folks who had an iPhone or iOS device. The other challenge we ran into that we didn't expect is, particularly with our corporate participants, is a lot of them, if they're using their corporate phone or iPad, have IT restrictions on what they can install on their device. And so a lot of them, they said it would take an act of Congress to allow them to put our application on their phone, so they weren't able to participate from that regard. So that had us kind of going back to the drawing board a little bit to figure out, well, what are some other ways that we could explore getting this information that doesn't have some of these same restrictions. And so we went in terms of complexity to the completely opposite end of the spectrum and said, what if we could just do basic texting? This would work on any phone, even a flip phone that's not even a smartphone. And what we could do is have them text in what their EOBT time or ready to taxi time is, and provide them back text messages about that two-way data exchange. And so that actually worked out really well for a lot of reasons. One, we're no longer tied to just iOS. Can work on any phone. It doesn't require installing anything because it's pretty much every phone can do text messaging. And for a lot of our corporate operators, they were already using texting as part of their workflow to contact dispatchers or to text people on the receiving end of the flight to tell them when they're going to be there. So the fact that they're already using texting capability, for other purposes, just kind of really fit into their workflow, and so they really like that a lot. But it's obviously not quite as visually appealing, and kind of limits the type of information we could provide back to the pilot. So we continue to iterate on other possibilities, and we've kind of settled on what's called a progressive web app, which is essentially it's a web page, but it looks and has the feel of an application. But because it's essentially being driven, by web technology, it works on any phone that can bring up a web page. But it has a lot more visual appeal than the texting capability, while also not being restricted to any particular platform. So we call this Pacer. So that's what we're using in Las Vegas and Dallas Love right now, and I'll talk a little bit more about that. But ultimately, and I want to drive home that point again, the user interface was not a primary focus of our research. It was more of a means to an end. It was a way to you know, how can we get the most participants to be providing us data so we can really analyze that. You know, ultimately where we see this going is we want you know, industry to be able to incorporate this into, you know, their applications and take some of the lessons learned, you know, that we found through some of our interface development into account. And so, you know, fill in your world's greatest pilot app right there. And we want that application to be able to collect departure readiness information and be able to display, you know, data back, such as like that airport demand chart or TMATs for the airplane if surface metering is in effect, expected runway, delay information, things like that. Okay, so the next couple slides kind of walk through a flow of how a pilot might interact with our application. So this is what we were using in Charlotte, and this is using the texting capability as an example. So we had a handful of flight operators, like Ernie mentioned, that we targeted as participants. I've just labeled them A, B, and C. So we found that, you know, they took on a couple of different flavors. You know, we had some that had, you know, one aircraft with a handful of pilots flying that one aircraft. We had an operator that had multiple aircraft, but you know, only a subset of pilots were flying each one. And then we also had an operator that had multiple aircraft, and any pilot within their you know, flight crew could potentially be piloting any of those aircraft. So what we did is we were able to associate, you know, the various phone numbers with those tail numbers, so that when a pilot were to submit a EOBT, in this case 2235, you know, the back-end system would then look to see, okay, what phone was this sent from, and does it correspond to a particular tail number or call sign of one of our participating pilots. If it had a so in this example, it would come back and say, you know, November 616 Papa Delta. Well, it would actually look to see, is there a flight plan associated with one of those tail numbers? So that's an indication that there's a flight that's has an intent to depart. And if it finds that match, it would then update the quote EOBT for the aircraft, you know, with the time that they submitted. Now, if there was multiple matches found, so let's say for one of the operators, both of the aircraft were planning to leave at the same time, the system would come back and say, hey, I found, you know, multiple matches. Are you talking about aircraft number one, you know, text one, or are you talking about aircraft number two, text two? Or if it was multiple flight plans for the same aircraft, so you know, sometimes flight operators will file for noon, 1 p.m., you know, 2 p.m., and maybe going to different destinations. If it found multiple flight plans for that, it would also come back with options that the user could then respond with, you know, which option does this submission correspond to, and then it would update the EOBT for that right submission. And there's other things the operators can do to that they can text, like you'll see in this, what it says, November 616 Papa Delta Charlotte to the Greensboro, RTT updated to 2235, leaving from Wilson Air Center. So if they happen to not be leaving from Wilson Air Center, and in the case of Charlotte, most of them are, they can text location, and it'll give them a list of locations that they can update if they're leaving from somewhere else on the surface. That location information is important. It is an element we send to NASA because that helps them compute an accurate taxi time, you know, based on what runway they're expecting that aircraft to go to and where they're at on the surface. You know, they'll compute a time to get to that runway end, and so that equates to the, or helps compute the target takeoff time. And there's some other information they can pull up if they text some keywords. And then, you know, as the back end scheduler system is crunching demand, as information for that flight gets updated, like its runway or target takeoff time, a text message will be sent, you know, back to that pilot with that information. So it might look something like this. It says this message contains predicted surface schedule information for November 616 Papa Delta. and it's advisory only. In this case, it's providing the expected wheels up time is 22:42 and expected departure runway of 36 right. So they submitted, 22:35, and they're getting an expected wheels up time of 22:42. So right away they know I'm probably not going to. I shouldn't expect any delay on the surface. That 7 minutes is probably the taxi time it takes to get from my, ramp area to the into the runway. So the pilots really like that information. So yeah, that's the texting example. So now what we're doing in terms of how we collect information using the Pacer web app, it's more button oriented. So we the pilots can select a date, and then within that date they get a series of boxes that correspond to 15-minute time bins. So in Las Vegas, we're using 15-minute bins since it's a little more strategic. In Dallas, we want something a little bit more precise. So when a user clicks on a 15-minute bin, it brings up a pop-up window that has them select another 5-minute window within that bin. And so that's the time that we send to the NASA scheduler, which then they can compute, what is this aircraft's impact on the departure fixed demand. What you also see here is a lot of these boxes are color-coded. Those color codes are representations of the expected surface demand. So this is where we're starting to blend several different data sources and present it to the pilot in the form of information, so that as they're selecting a time, they have better awareness of what to expect in terms of surface demand at that time. So red is typically an indication that more aircraft than or have indicated that they're going to depart in this bin than what the capacity typically is for that time period. And orange is I think right about at capacity, and if it's green, it's something less than capacity. And of course, the pilots can use any web-enabled device to do this, and sometimes it's not even pilots. Sometimes these operators have dispatchers that enter the information, whether it's via a laptop or a phone or tablet, so it provides some flexibility. Notifications are another feature that we found useful. So I've already shown some notifications, such as the expected runway, target takeoff time, but we can also enable other types of notifications, such as, let's say, a pilot indicates that they're going to depart. Let's say it's 12 o'clock now, and they submit an EOBT for 12:40. And let's say at the time they submitted that, the surface situation looked pretty good. Maybe they were in a green bin. And let's say 10 minutes later, an influx of information has come in that now indicates that that time bin that they selected is going to be red, or it's going to be busy. We can set up notifications to send the pilot an indication that the situation is changing. You may want to revisit what the demand situation looks like, and if you have flexibility, you might want to consider something else. But this at least gives them an awareness. Even if they don't have the flexibility to change, they at least are aware of what to expect, and they can communicate that to their customers. And so it just helps improve overall situation awareness and informed decision making. So this slide, I think the main takeaway is that these capabilities are very much data driven, and swim is a big part of that, although not exclusively swim. So what we're doing in Vegas and in Dallas in terms of generating that demand picture that we're presenting back to pilots is we're layering in several sources of information to inform that demand picture, and a lot of times it starts with airline schedule data. So Innovata is a source of information that contains airline schedules, and that can be, I think, up to 6 months in advance. So it kind of starts with that data, your scheduled operators, and then as airlines submit early intent information, which is coming into TFMS, we can bring that information via SWIM and update the schedule information. And then as we get even closer and flights begin to start submitting flight plans, we can pull that information from the SFDPS feed, SWIM Flight Data Publication Service. So that includes flight plans, and we can again update, do some matching to update the early intent information if there was some. And then, of course, as you get even more tactical, and you're talking about inputs from a web application or app, again, that would refine that demand prediction information even more. So it involves data and data fusing. If you were part of the session before lunch, you heard a lot of discussion on fusing and matching of data. A lot of that applies to these the applications we're developing too. We definitely have to do flight matching across those different sources. And there's a lot of different ways you could do that. We're using not just goofies, but call signs, origin destinations, time entries to try to do these matching. Sometimes it can get complicated for some of the aircrafts that are doing shuttle service, particularly going back and forth to the same destination over and over. You might see multiple entries, and you have to make a decision about, is this a single flight that just happened to file multiple flight plans, or is it truly a flight that intends to make that trip multiple times? So those are some of the gotcha cases, those edge cases that I know NASA's been dealing with too, with ATD-2. I say access and identity management is also an important component of this. That's really what's needed for a lot of our two-way data exchange. We want to make sure that when we're sending information back to a pilot, that it's going back to the correct pilot. And a lot of information, particularly when you're dealing with GA and business aviation in particular, a lot of them aren't really interested in having their flights, tracked everywhere. So a lot of them submit their tail numbers to the block list, which prevents people from putting their tail numbers into sites like FlightAware and tracking where they're going. So that carries over to applications like this. We've got to be careful that we aren't exposing information for those flights that don't want to be tracked inadvertently through our applications. So we've taken a lot of steps to incorporate that block list into our tools. But at the same time, we want to still make information available to those who are authorized to view it. So we've wrestled with that a little bit. And a lot of that is just research artifacts. We envision if industry were to take over doing this, and you were going to implement some of these capabilities through existing flight planning applications, those are already set up with accounts for users. So a lot of that may already be accounted for. That wasn't something we were set up to do, so it was kind of a learning experience for us. But having different user roles or user types has allowed us to kind of customize the information we send back to various users. So when talking about the application we're doing in Las Vegas, we have a view for the pilot to submit information and get that demand information back. We're relying on the FBOs, the fixed base operators as well, to help us keep that information up to date. But the view that they need might be different than what a pilot needs, because oftentimes when a flight arrives at an FBO, they usually have a representative meet that flight to capture when they plan to leave and at what time and what sort of fueling requirements they need. So that's another source that we're trying to leverage to help keep this information up to date. Certainly, if some of these operators have multiple aircraft and sort of manage a fleet, they might need a different view or a different interface, so they can enter multiple times for multiple aircraft simultaneously. That's particularly important for some of the fractional ownership operators, and we've had discussions with them about their needs too. And then even airports, airports could also be potential users of this, and their view is obviously going to be something different than, say, what a pilot is using. So, being able to distinguish those different roles and provide different views has been, a lesson learned and something that's important. Okay, let me just see if there's anybody has any questions so far. Okay, we got a lot of questions. So let me, before I move on, let's see if there's some that we can answer quickly. Yeah, I figured I'd get a lot of questions about security. I'll say that is a current focus of research. I don't think we have the answer to that just yet. I mean, what we're doing is definitely secure. I don't want to give an impression that it's not, but yeah, some of the things I talked about with like the bar list or having some sort of authentication. There's other parts in the FAA that are researching identity management. So we're in close contact with them, or soon will be, about some of their ideas of how they authenticate users, and hopefully we can leverage that, or industry can leverage that as a way to make sure this information, security is maintained in the transmission of this information. Okay, so there's a question about benefits. I do have a slide about benefits that we'll talk about. And I see, integration with already popular apps like ForeFlight. So yes, that is really where we see this going. We've have a research agreement with ForeFlight. I think Garmin and a few others. So we're definitely in conversations with them about how they can incorporate these sort of capabilities into their apps that the pilots are already using for their flight planning, because that's really where we see this kind of logically fitting. We don't really see necessarily that a separate standalone app is needed. Most of the feedback we've gotten from the operators is that, yeah, they would like it to be in the context of the tools they're already using. So that's very much in alignment with where we're going. So just a quick slide here about some of the things we see that if industry were to take this on, some things that they might need to think about, or some things that would kind of fall onto their shoulders to do. First would be to develop and/or integrate this sort of capability into their apps, particularly ones that are already being used and that correspond with their typical workflow. Incentivizing, that's something we've had to wrestle with quite a bit, because we're sort of introducing this new tool or new capability, that sort of adds to pilot workload to some degree. Again, it's more of a research artifact, but at the same time, we want to be able to expose some benefit to these operators for providing these times, and at least make them aware that by providing these times, we can actually give you additional information back that you don't already have. And so that's really been one of our research questions is what is that information, that carrot that really entices people to want to do this every time they're ready to fly. And so we're continuing to work through that. I think if this were to be integrated into existing apps as part of that workflow, maybe that incentivizing issue isn't quite as big. But if you're trying to get somebody to do something that they're not used to doing, you usually got to provide something back. But again, once you provide that connection, to Swim, and you're able to bring in a lot of new, rich information that Swim provides, I mean, I think there's a lot of good information in there that'll incentivize participation. Collecting, validating, and forwarding this data to the FAA is another piece of this. And there may be some responsibility of the service provider to do some sort of validation or at least some sort of checking of the data. Again, we want to make sure we're not introducing bad data or data that's worse than no data. So somebody would have to sort of be responsible for doing that. And then this harmonization. We've talked about at the beginning of the presentation some of these terminologies that A lot have come out of the CDM community, but are maybe geared more toward the airline operations. Helping to put things in terms that the GA and business jet pilot understand, I think will go a long way towards helping to encourage adoption. And this last one again about data quality. As CDM members, airlines sign agreements to provide information in good faith that's accurate. I think there's some questions about. We're not necessarily suggesting that the business pilot is a CDM member and is subject to these the same rules that an airline has agreed to, but there's that service provider that kind of provides that middle layer to send and receive information on behalf of that pilot. Perhaps they are a trusted third-party entity. Whether that means CDM member or CDM participant, I think there's still some things we need to work out in that space in terms of what does it mean for industry to be a player in this space and exchange data on behalf of users. I think there's a lot of questions that could still use refinement in that area. I don't know if you have anything you want to add to that.
No.
Okay. So just to, again, highlight sort of a notional use case of, the future state of where, an application provider is providing a service to a pilot, where a pilot is using an app to submit their departure readiness time, in this case, 1925, as well as their parking location is West Ramp. So that would flow to the application service provider's back-end servers, who would then forward that information on to the FAA via SWIM interface, in this case, the probably TFMS, the TFMM data feed, request supply feed. So that includes that EOBT and parking location, which then is sent to, or consumed by FAA scheduling systems. TFDM would obviously be a recipient of that EOBT time, and the controllers use that information, and the automation systems use that information to come up with traffic management plans and publish information back out via TTP, which then would be consumed by that application service provider and then forwarded back to the pilot, and would include information such as expected departure runway, expected taxi time, wheels up time, and if there's any traffic management delays. Let's see, I said something about TTP. So, we're currently, demonstrating a lot of this, with NASA using their prototype TTP feed, which is on the SWIM Research and Development Network. But, in the future, we envision this being all production SWIM transactions. Okay, so now to some benefits. So the benefits of this, range, not just for ATC, although it definitely gives ATC a better view of what the demand is going to be on the surface, to allow them to make better decisions about what sort of initiatives to put into place, and as well as what sort of bounds to put on those. You've heard in some of the earlier sessions that the greater the uncertainty, the larger the buffers that they put around these initiatives. And so if you can refine your demand predictions, increase that predictability, and reduce that uncertainty, you can start to tighten up those buffers. So that ends up potentially delaying flights less if you can have more targeted initiatives. It gives flight operator more visibility into scheduling and sort of where do they fit into the schedule via that two-way data exchange, and so they can make better decisions about when to prepare to leave, when to turn on their engines, so they can reduce fuel burn, reduce engine runtime. We've heard that specifically from one of the operators in Charlotte, is that when they get that target takeoff time, if it's more than 10 minutes, they won't even bother to turn the engines on, and they'll just wait until it gets closer to their target takeoff time before they fire up. let's see, better scheduling of resources. So again, being able to take better advantage of the capacity at the airport or in the airspace. These times again help to tighten up and build more predictable schedules. I've mentioned several times, being able to get access to information that the pilot wouldn't normally have access to, via this mark. And this is my last slide, so we're almost done. And I mentioned the buffers, greater predictability. I think I said all those. Okay, so that wraps up my presentation. Thank you. We probably have a couple of minutes to answer a few more questions. So let me see what we have on the. So I do see a question about poor data quality can impact demand predictions and how to enforce that. So yeah, I mentioned that that's definitely an area we need to look into. Also, gaming of the system is another. We want to make sure, if a pilot puts in a time and they don't really like the result they got back, like, are they going to keep probing the system with slightly different times to see if they get something better? We don't necessarily want to encourage that. So yeah, there's a lot of things to explore in that sort of policy procedure space that I think would need to be ironed out. And certainly the CDM community may be a place where a lot of that is discussed. Let's see. Yeah, see pilot spamming the system. Yep. Okay, so we have a question about can I use it outside of GA? Yeah, I mean, we've talked about some of these operators that maybe aren't CDM participants, like the internationals, and how might they participate in this? And yeah, maybe it's an airport submitting information on behalf of those operators. I don't think anything necessarily prevents it being used outside of GA. I think the infrastructures and things put in place for the airlines, through SWIM are going to be a lot more powerful and feature-rich than using apps. But I think what we're showing here, or what I've talked about here, we really see as just some initial applications that are enabled by SWIM. And there's certainly a lot of other applications that I'm sure industry could invent up, leveraging that same data, whether it's being used by GA or whether it's being used by mainline carriers or airports. I think there's a lot of possibilities for doing some pretty cool things using mobile technology.